Hello everyone. In this session, we are going to discuss about network protocols. So from the word protocol, you might have heard about it, right? So protocol is a set of rule or it is nothing but a rule, right? Protocol is equal to a rule. And when I say rule, why exactly we need a rule or why exactly we need some kind of protocols in the network? So there are multiple different protocols that are available in the internet or in the network for three different major areas: for doing data communication, for managing the systems on the network or managing the devices like routers or switches or servers on the network, and also to safely and securely transmit data or send data, right? So there are three different categories of protocols: communication protocol, network management protocol, and network security protocol. So this is what we are going to discuss in detail in this particular session. See, let's take a step back again. So when I say protocol, see, if in the network we are trying to have communication established between two devices or multiple devices in a network. If two devices want to talk to each other, definitely there will be a sender, there will be a requester, or there will be a receiver, or there will be a device which will answer to the requester's information, right? So in order to govern these data communication, we need to have a set of rule, right? For example, if you take network communication, what can be communicated, when it can be communicated, how it is getting communicated. See, all these are set of rules and restrictions, or maybe I would say these are all some kind of policies that we have on how to have a seamless data communication using some of the network protocols in a maybe on the same local network or in the network, right, in the global network. So there are variety of protocols like TCP/IP, HTTP, IP, and all those things. So we'll deep dive into each of these one by one. So looking at this particular screen, you can see that we are having the TCP/IP model, not the ISO/OSI model, but in the TCP/IP model, you can see IP is at the heart of anything. See, without an IP address, without an internet protocol, none of the communication can happen. See, the device has to basically have a IP address. That's where things starts, and then you can have connection oriented or connectionless at the transport layer, and you can use different application for sending emails or accessing HTML pages or CSS style sheet or whatever, right? So all these are happening through the basic IP address, and at the physical level, you need to have a Ethernet card or a Ethernet protocol that can allow you to reach a particular device or reach a particular system. So, like in human communication, there are certain common things, right? So, if, for example, if one person want to talk to another, so they need to have a common language, right? They should have a common language. And also, see, if I am speaking very fast, or if my delivery is too fast, then the other person cannot understand it, right? So the speed, and also, if I'm continuously talking a lengthy sentence, will that be of any use? No, right? So there should be a kind of size actually. For example, if I'm talking a sentence with 100 words without non-stop in a single sentence, it won't make sense, right? Or also it will be very difficult for conveying that information to the other side. See, at the end, whatever I'm conveying, there should be an acknowledgement, right? That's where you guys say like, I'm speaking too fast, or I'm not able to convey the message properly. So I need to get a confirmation whether the packet got delivered or not, whether the packet was acknowledged from the receiver side. So those things are very, very important, right? So I need to get a confirmation in network terms. We call it as acknowledgement, right? So confirmation and acknowledgement. And also you cannot just keep sending packets without a proper timing control. So there should be a flow control, how much we are sending, and there should be a timeout also. So if the receiving system or the other end of the system is not at all available for 1 hour, 2 hours, then you cannot keep all the messages stagnant or waiting on the network, right? There should be a timeout for the messages to try the delivery, and then if it is not able to be successfully delivered, then there should be a timeout until after which it has to get to the dead letter or the dead queue, right? So there will be a sender, there will be two different persons in a network who will be sending and receiving, like two different humans who are interacting. So all these above stuffs are called protocols. Okay, let's understand the same above aspects from the network point of view. So even in the network protocol, we are defining the rules and conventions for the communication to happen between two different devices or multiple devices, right? So there should be common language, common aspects between these different systems. So in network aspect, so these five important stuffs can be called out this way. So message encoding. I'm not sure how many of you understand this term encoding, what exactly it is used for. See, for example, here I have a sender who's the source of the message is from a particular person who's sending it for or sending it from a system. So the message is getting encoded here. And why exactly we need to encode? See, the encoding will happen based on the transmitter medium or the transmission medium. See, if you are sending it via system, wired network, then the traffics will be in packets and then the frames. Whereas if it is sending through the wireless medium, then it has to be waves, right? It cannot be the same mechanism. So it has to go through the waves and then it has to reach the destination. So based on the transmission medium, the data that we are sending will get encoded, and then after it is getting received, it will get decoded before it reaches the other system. So that is what it is needed. So message encoding is very, very vital and very basic stuff, which is part of the uh, protocol or network communication protocol. So above is some example that I talked about, human to human communication, right? So these are all some protocols that are all for human interaction or human communication. But in the network, if you want to send some data, we need to do message encoding, and then there will be a sender, there will be a receiver, right? There will be two parties, right? And we should have a agreed formatting, what kind of message, how the message should look like. And we should also have time control, flow control and timeout on the network, like how I'm delivering the uh, content in gaps and so on, right? And there should be some kind of message size. If you look at or if you recall 20 years back, if you're sending a text message, it can be very few bytes, but nowadays you can send huge lengthy emails, or even in your WhatsApp or anything. Nowadays you are able to accommodate more big size messages, but still there is a limit, right? Even as on date, you cannot send a single WhatsApp message beyond a particular set of words or characters, right? There is a limit still, but the technology is evolving, the network bandwidth is getting increased, the network is getting better. So automatically the size that we can send, or the data that we can transmit in a single frame or a single message, it has evolved, it has changed. So, but still we are breaking the messages into smaller parts or smaller sentences. When as a human, when I'm delivering something or when I'm sending something, I'm splitting it into sentences, right? I cannot just have a single paragraph with thousands of words. That won't make any sense, right? Similarly, we also need to have a message delivery option, whether we are sending it to a single person, or whether we are sending it to multiple systems, or whether we are broadcasting it to all the systems on the network. So message delivery options, it differs. So there are many different protocols for different purposes. For example, if you're talking about sending a file, we generally use a FTP, but now after a lot of security enhancements, we are sending it using FTPs or secure FTP solution. If you're talking about accessing HTML pages or objects, or maybe videos, audios, and all those things, we use HTTP protocol. But now after all security issues and stuff, we are using secure HTTP, SHTTP, or HTTPS. Right. Similarly, on the network level, we use SNMP for management and so on. So we'll get to understand what are the different protocols that are there in each of these cases. For network protocols, for communication, we are using IP. IP is the base of this is where all the communication begins, right? IP is responsible for basic networking, internet protocol. The system should have IP version 4 address, or it can have IP version 6 address also. So it is a numeric address through which we are identifying a particular destination, a system, similar to our address, home address. Without a home address, we cannot reach a particular place, right? So there should be address to deliver something. Similarly, in the network, we need an IP address to deliver a particular packet or a particular message to a particular destination or a particular system. So IP is the base for everything. So TCP and UDP, like we will have detailed discussion. We will have a comparison between them, and I will explain it in details. But for HTTP, like if you want to have some HTML pages accessed, or access some of the backend CSS style sheets, or if you want to access some videos or audios, so you are using HTTP hypertext transfer protocol. So hypertext transfer protocol is the medium through which, or protocol through which you are accessing the HTML pages or the CSS style sheets through the internet browsers. And nowadays it has become a secure protocol, HTTPS, where we are combining HTTP, and we have a layer on top of it using SSL, right? Secure sockets layer. And nowadays we also have TLS encryption, which is an advanced version of SSL. And even within TLS, we are having multiple versions, right? For basic communication, we are using some specific set of protocols. And in order to manage, monitor, and maintain the network systems, the systems in the network, like your routers or switches or your servers or laptops or desktops or mobile devices, we are primarily using SNMP, right? And second most commonly used one is ICMP. So there are other protocols which are all coming under the management, maintenance, and monitoring category, but SNMP and ICMP are the two common major important protocols. So similarly here, TCP, UDP, IP are the most common ones. Similarly here, SSH is very common to access the network in the systems in the network, and then for file transfer, for email transfers. So these are all very common protocols. For web applications, we are using SSL or TLS. So these are all very common for each and every different categories of security. So let's understand one by one. First, we will start with the network communication protocol. So to get communication done in the network, we are having varieties of protocol. For web layer, we are having HTTP, and then for transmitting the data, or sending and receiving the packets. So in TCP, in transmission control protocol, we are separating the data into packets that can be sent or that can be shared over a network, right? It can be sent using systems or devices like switches or routers to the destination machine, right? The packets can sent via many different devices. And in UDP, the main difference is UDP, you will not get a kind of acknowledgement, or it will not kind of have a it will not ensure that the connection is made between the application and the server in UDP. But in TCP, that will definitely be made, because if, for example, in TCP, the examples are we are accessing and browsing the machine websites, and then we are sending the email. So those are all good examples of TCP. Whereas in video conferencing, it is not that the one of the requester can also skip it, or one of the person can also not attend it. So even if you talk about some of the chat messages and all those things, so here I have given live chat and then other examples, right? There is one more which is missing on this particular protocol list, which is IRC. IRC is nothing but internet relay chat. It is a text-based communication protocol. So if you are just sending a text SMS, or sending messages to other client, so it uses internet relay chat. Similarly, if you are sending emails, or if you are sending files, there are different protocols that are there in the network communication categories. So for emails, for files, for video conferencing, for chat messages, for web browsing, for IoT and virtual reality. So there are varieties of network communication protocol. So these are the protocols that are used for ensuring your communication is happening across the network. So network communication protocol, it not just sends the data, it also handles the authentication, the error detection, if there is a issue in the syntax, or if there is a semantics error. All these can be identified using the network communication protocols, which are listed here, right? These are all very, very important to understand. I will also have one more detailed session where I will explain each of these protocols, or the very common protocols in minute details. So when it comes to management, when it comes to monitoring, maintaining, and managing the systems on the network, when I say managing the systems on the network, not just on the local area network, even on the internet also, this simple network management protocol is the de facto standard for managing, monitoring, and maintaining the systems in the network. Okay, it can be on the local area network, or it can be in the wide area network, or even it can be on the metropolitan area network. So there will be SNMP manager server where you will have an agent installed on all the network devices, SNMP agent. You will configure it either on the routers or switches or servers or laptops or whatever devices, right? Even on the printers, you can have the SNMP framework that can be used for managing and monitoring, and even for maintaining the managing the systems on the network. It can be over the router, or it can be through gateway devices. It can be on the LAN, WAN, MAN, all those stuff, right? So this is the most common protocol that is controlling, that is completely monitoring all the set of systems using the agents on the network. Now there are two commonly used protocol. The other one, people underestimate the power of ICMP, right? See, people only think that ICMP is only for doing a ping packet and then getting a response. See, as part of the ping packet, it not only acknowledge, it gets the acknowledgement, it also gets the diagnostic purpose also. You can use it for using the ICMP protocol. See, ICMP protocol not only provides a response, it can also provide you clear error messages. What exactly is the problem, what is the type of problem that we are getting, what is the type of error we are receiving, what is the response for our query, what kind of number. So based on each of the number, there are different messages it corresponds to. Okay, so ICMP is a very common, most widely used protocol for reaching or testing the reachability of the system in the network, right? Or if you are trying to reach a host, or if you are trying to reach a system on the network, ICMP is the base protocol. Some people call it as ping protocol. Okay, that is fine. So we are checking the connectivity, whether the system is reachable on the network. If it is not reachable, what kind of issues that the system is going through. So ICMP, it's like more or less we are just sending it to a single machine. It's a unicast way of diagnosing and reporting the state of the system on the network. So it will tell us whether the system is reachable or whether there is any issues that needs to be diagnosed. Next, third one is network security protocol. So it is a very critical element, right? So how do we prevent unauthorized access, unauthorized users to access the application, unauthorized devices to be added on the network or connected on the network. So we have a lot of challenges, right? We need to protect the users, protect the application, protect the data, protect the devices. We need to understand a lot of protocols here, but there are very common and most commonly used protocols that are there. See, people whenever they think about security, the first couple of things that comes to their mind is what? Encryption and cryptography, right? To secure the data. That is good. Okay, so you know a method to protect your data. The common method is having encryption enabled. Okay, that is fine. But beyond that, for each and every layer in your ISO OSI model or TCP/IP model, for each and every layer, there are wide varieties of protocol. See, this did not start yesterday or day before, right? So these kind of stuffs are there in the market for 35 years. So at the beginning of 1990s, where the web communication started, so there was a need for protecting the web protocols. Or whenever we are accessing through the web browser, we want to ensure that all the information that we are accessing is staying private and free from the attack. So how did we prevent it at that time? So that's when we had this SSL. SSL was invented around early 1990s, and then this was not enough, because there were a lot of different stuffs that we need to protect. So in the network, people started sending emails, messages, VoIP connection, and all those things. So then the International Standards Organization decided SSL is not enough, and we need to enhance it. That's when around 1999 they they started with TLS as a replacement for SSL. TLS is transport layer security. See, since it came as a replacement, a lot of people use SSL as a metonym for TLS. That's fine. Okay, so you can use these two things interchangeably, but the purpose is different. The security aspect that it brings is different. For example, SSL is mainly to protect your login information, username and password, your certificate. Those things can be, your identity can be protected using SSL primarily. But the connection, the data transmission, the data communication can be well secured using TLS. TLS stands for Transport Layer Security. Your data privacy, data integrity on the communication, when the data is getting transmitted, the transport layer security is very, very powerful. Not just accessing the website or not just web application, even anything that you access from a server, or it can be in the format of message or email or VoIP or whatever. So this IETF invented TLS, Internet Engineering Task Force, stands for IETF, right? So IETF stands for this Internet Engineering Task Force. They are the one who proposed this TLS standard for as a predecessor for SSL, right? So there are multiple versions. Recently, 3-4 years back, I heard there is a new version, Transport Layer Security 1.3, and even there is a new version that is there. Okay, so this is the SSL and TLS are the gold standard for securing your web application and web access mechanism, right? If it comes to file transfer, then there is a different protocol, right? You have SFTP. So SFTP is for file transfer security. SSH for securely accessing the systems on the network. When you are accessing through VPN channel through the tunnel, IP security is what is being used, and we have the web application protected using SSL and TLS. So there are other protocols like HTTPS, and there are other protocols like PEM. There is another one called SHTTP, SET, PGP. So I will explain all these protocols in details. But for now, these are the top 5 protocols that you should be aware of when it comes to network security. And also these are the port numbers that you need to be aware of for each of the SSH and SFTP works on the same port 22, and IPsec is on 500, and HTTPS, right? The SSL and TLS, they are all on the port number 443. And yep, so these are the stuffs that we need to be aware of when it comes to network security, and you need to be aware of what protocols to use for securing our systems from unauthorized access in the form of users, in the form of devices, or in the form of services. So we need to ensure that we are using secure protocols like SSH, SFTP, HTTPS, and so on. See, these things are very, very vital if you are a solution architect, or if you are a person who is in charge of providing the solution for securing the network communications. People will tell you every single layer or every single communication that I do has to be secured and encrypted, right? So how do we establish that? So we need to understand which protocol can be used for a specific purpose in order to secure the network. Okay, so stay tuned. We will get to understand all these stuffs in a very detailed way. And feel free to ask any questions that you might have in the chat or in the comments.